Welcome to mixing problems. So the general idea here is we're mixing two solutions with different concentrations. So we're mixing two solutions with different concentrations. Of some substance. We'll be focusing on saltwater solutions. So for this, what we're going to think of is we will have a main tank that has some solution in it. So this is our main tank. And this will be our primary solution. Then into that tank, we will be pouring our second solution. So this will be our second solution. And at the same time, we might also be draining. So maybe there's a little spigot and we're draining the primary solution. And I need to update my screen. So we have our second solution is flowing in. And then we have our primary solution is flowing out or draining out. And so that second solution will remain at a constant concentration. The primary solution will change as we have water added, solution added and draining out. So our second solution stays at a constant concentration. And our primary solution the concentration changes. Okay, because we're pouring in the second solution and gaining some of the overall, or losing some of the overall solution. So as we add the second solution, and drain some of the primary solution. So what we are going to focus on here is the actual quantity of substance in the primary solution. So we will focus on the quantity of, in this case, salt in the main tank. So in the primary solution in the main tank. And we will be focusing on pounds. So the quantity, or pounds, of salt in the main tank. And so we will create a differential equation sort of describing how that quantity changes as solution is poured in and solution is drained out. So we will form a differential equation. To model how the quantity of salt in the main tank changes. So what we'll do is we'll set Q, or Q of T, to be the pounds of salt at time T of salt in the main tank at time T. We'll usually be looking at T in minutes, but that could change. And what we'll have is our Q prime should be the rate that the salt is added minus the rate that it's subtracted. So we often write this as rate in minus rate out. To find each of these, we will do the concentration. So the rate in, we're looking at the concentration of what we're adding. So this will be the concentration of the second solution. Often that will be in pounds per gallon. And then we'll multiply that by the amount of gallons we're adding per unit of time. So our sort of unit conversion, the gallons will cancel out, we'll wind up with pounds per unit of time. For rate out, same idea here. We'll do the concentration of the main tank, or of the primary solution. Again, this should be in pounds per gallon. And then we will multiply by the gallons per unit of time. So again, the trick here, the concentration in the second solution remains constant. The concentration of the main tank is changing. But it can be found by doing whatever our quantity is, the pounds is at time T, and divide by the volume at time T. So we will have two cases. We will have a case where the volume remains constant. So say we add 5 gallons per minute and drain 5 gallons per minute. So we'll have two cases. We'll look at two cases. Case 1, the volume in the main tank, volume of solution in the main tank remains constant. And case 2, we'll look at what happens when the volume of solution in the main tank changes. But again, our main thing here, as we're looking at rate in and rate out, we're going to focus on the concentration times the rate of the solution being poured in. So the concentration in pounds per gallon times the gallons per unit of time being added. And then we'll look at the concentration again in pounds per gallon times the gallons per unit of time being drained out. Sticking with that Q prime equals rate in minus rate out is very helpful for all of these problems. So in the next video, we'll go ahead and focus on what happens when we have constant volume, and then we'll do an example in the following video when we have changing volume.